Hey there, grade 10. So hopefully from the Discovery 1 from 15A, you found out that for a particular angle of a right angle triangle, the ratios are the same. They're all the same. So we're going to talk about those ratios today. So from your Discovery, you should figure out that one of the ratios was opposite over hypotenuse, and then adjacent over hypotenuse, and then opposite over adjacent. Okay, and then just a bit of a reminder, the opposite side of a right triangle with angle theta here, this one is the opposite, this one is the adjacent, and this one is the hypotenuse. Okay. All right, and then so these ratios, they have some traditional names. So opposite over hypotenuse, we call that sine theta. So sine theta is equal to opposite over hypotenuse. And then the adjacent over hypotenuse, that is cosine. So how you would pronounce sine here is like sine, not sin, but sine. And then this one is cosine. And then tan here is tangent, short for tangent. Okay. So how do I remember what these are equal to? This is what I've always chant in my head. So notice that sine equals to opposite over hypotenuse. So sine equals to opposite over hypotenuse, right? And then cosine is adjacent over hypotenuse. So I would take the first letters. So cosine adjacent over hypotenuse. And then tangent is opposite over adjacent. So that's tangent opposite over adjacent. So I would always chant SOHCAHTOA so that I remember these ratios here, and you should too, because I have not forgotten this since middle school when I learned these. So SOHCAHTOA, this is how you remember it. Okay, and one thing to note, that sine theta divided by cosine theta, so that means again sine theta is actually so opposite over hypotenuse divided by right, adjacent over hypotenuse. If you do this like a fraction, like a division of fractions, you flip this, the hypotenuse would cancel out and you would get opposite over adjacent. And notice that is equal to tangent theta. Okay, so I have SOHCAHTOA again in the bottom so you won't forget. So actually sine theta over cosine theta is equal to tangent theta, which is quite interesting. The ratios divided by each other is equal to another ratio. So if you forgot that, I mean, you could come up with it, but the only thing that you need to memorize here is pretty much SOHCAHTOA, and it's pretty easy to remember that, right? SOHCAHTOA. Just remember how to spell it, so you know. So it's useful for you. Okay, so what do we need these ratios for? It's a really good question, right? Like, why do I need to learn all these things? So the first one is find the value of x to correct to 2 decimal places. Do you ever wonder how, if you know the angle of something and one side of it, but you don't know the other side? So how do we find that out, right? So that's what trig is for. We are going to find the sides of a right triangle, because it's not always the case that everything is given to you, right? So what would happen if we need to find the side of a right triangle. So this is what you would do first. Okay, I would label what is given to you. So a reminder, this is always hypotenuse, and whatever side that's opposite the angle that's provided, that would be opposite side. And then whatever is next to that angle is adjacent side. Okay, so which one do we use? Sine, cosine, or tangent? So right now we don't really care about hypotenuse, right? We only care about opposite, and we're looking for adjacent. Okay, what ratio, if you go back, has opposite and adjacent? That would be tangent theta, right? So tangent theta is equal to opposite over adjacent. Okay, so we're trying to find adjacent here. What you can do is you can swap adjacent and tangent theta, because if I were to multiply adjacent side on both sides, I would get adjacent times tangent theta equals to opposite. And then you could divide tangent theta on both sides. And notice that this would equal to 1. I could get rid of that. So pretty much I'm just swapping them, right? You could do this in all of these things. You can just swap them. So opposite over tangent theta, my opposite side is 80 centimeters. And tangent is a function, and I will show you on your calculator. Tangent theta, and just plug in your 74 degrees. Okay, and then we just need to calculate. So let me show you how that works. So we have 80 divided by, okay, hold on. So 80 divided by tangent. So tangent is above the closing parentheses, like 2 buttons above 9. Tangent 74. Okay, and then before you do anything, we're just gonna check if your calculator is on degree mode. So degree mode, I meant like 74 degrees. To check that, you can click on mode. It's next to the blue button. See, my calculator right now is in radian. It shouldn't be in radian, it should be in degree. Okay, select that, and then clear. And then now we have that adjacent is equal to 22.9396, so it's 22.94 centimeters. You see how easy that was? Yeah. So make sure you know how to use this. All right. Okay, so we're gonna go to the next one. I'm gonna keep your calculators open. For this one here, again, I'm gonna label my sides. These are opposite, and this is adjacent. Okay. So this time here, again, this is still tangent theta, SOHCAHTOA, opposite over adjacent. I could plug in the 27 now, 27 degrees, which is theta. The opposite we don't know, and then the adjacent is 11. So in this case, to solve for x, I need to multiply both sides by 11. So I'm going to calculate tangent of 27, and then I'm going to multiply that by 11. So I get x is equal to 5.60 millimeters. There you go. So we're gonna do some practices in class, and if you have any questions, please let me know. See you guys.